So let's begin by looking at section 5.1 today, which is entitled The Greatest Common Factor and Factoring by Grouping. Okay, to start with, what I'd first of all like to do is define what it means to factor, and we'll do that in the form of an example. So let me write down the word factor, and let's factor a number to start with. Let's factor the number 20. Well, to factor something, what am I asking you to do there? What I'm asking you to do is, express 20 as a product. So how can we factor 20? One way of factoring 20 is to write it as follows. 10 times 2. That's one way to factor 20. Are there other ways to factor 20? Yeah, there are other ways. Let's see, 4 times 5. Any other ways to factor 20? 20 times 1. What else? Oh, we could do something like this. 2 times 2 times 5. Let's check. 2 times 2 is 4, times 5 is 20. So there are several ways that we can factor 20. Factor, in words, means to express as a product. So let me write that down. Factor means to express as a product. To factor means to express as a product. Okay? You can factor numbers, but you can also factor polynomials. And so most of the time in algebra, what you're going to be doing is factoring polynomials. So let's look at some examples. First example, A. Let's factor the polynomial 15x cubed. So let's factor 15x cubed. Well, I want to write 15x cubed as a product. And there are several different ways you could do that. One way is you could say, okay, this is, in fact, 5 times 3x cubed, right? A product of 5 and 3x cubed, and that gives you 15x cubed. That's one way to factor 15x cubed. What else could you do? You could do 5x times 3x squared. That's another way to factor 15x cubed. 5x times 3x squared gives you 15x cubed. Or what else could we do? We could do negative 5x squared times negative 3x. Negative 5x squared times negative 3x. That also gives us 15x cubed. And in fact, we can keep going on and on and on. Let me just write etc. There are many different ways to factor 15x cubed. The idea is once you get one term to your factor, one term to your factorization, then you can get the other term easily. So to factor means to write as a product. Let's look at another polynomial. Let's look at example B. Let's look at this polynomial. I want to factor 2x plus 6. Factor 2x plus 6. Now, what makes this one different is this is two terms, unlike anything we've done before. To factor something that has more than one term, the first thing you want to do is factor out something called the greatest common factor. And what you want to use to do this is something called the distributive property. So I want to write the distributive property just to remind ourselves what the distributive property says. Distributive property says the following. It says that if you have A times a quantity B plus C, remember this is the same thing as taking A times B plus A times C. Remember, this is the distributive property. Well, when you factor, you're going to use the distributive property, but you're going to use it in the reverse process. Meaning, instead of starting with A times this, we're going to start with this part here. We're going to start with A times B plus A times C. So some number times some value B plus some number or some expression times some value C. And what we're going to do is we're going to say, okay, let's write that backwards. I can take out the A from both of those quantities, and what I'm left with in the parentheses has to be B plus C. So we're going to use the distributive property in the reverse order to factor the polynomial 2x plus 6. Okay, so let's go back up here to 2x plus 6, and we're going to factor this polynomial. Okay, so first thing you want to do is find some number or some expression that is common to both this term and this term. And in fact, a 2 is common because 2x is 2 times x, and 6 is 2 times 3. 2 is a common factor in both 2x and 6. So once you get that common factor, you pick the largest one or the greatest one you can think of. I'm going to underline it right there as my common factor. I'm going to use my distributive property and I'm going to take it out. So I'm going to write 2, and then I'm going to put a parentheses. If I take 2 away from the first term, I'm left with x. And if I take 2 away from the second term, I'm left with just 3, right? Because if I've taken the 2 out front, I'm left with just 3. And if you check, 2 times x is 2x, 2 times 3 is 6, and so you actually get the above polynomial. And this is a factorization of 2x plus 6 because it's a product. It's 2 times a quantity, and that's a factorization. Okay, so we're going to keep using the distributive property, and we're going to do some more examples of factoring polynomials. This is example C, and let's write down 4x squared minus 4x, and again, we're going to factor. Okay, so we're going to factor. First thing you want to do is you want to figure out, is there anything common here and here that you can take out? Well, if you think about it, 4x squared is actually 4x times x, right? Double x, x squared. And over here you just have 4x. Okay? And what's common in both of those places? In both of those places, you have a 4x here and here. And we can take that out because it's common. So using the distributive property, let's take out the 4x. And what are we going to be left over with? And let me write that a little darker again. That's 4x. We're going to be left with the following. When you take 4x away from the first term, you're left with x. Minus. Now, when you take 4x away from here, there's nothing left. Well, actually, there is something. Actually, 4x times 1 is 4x. You're left with the number 1. And let's double check. 4x times x is 4x squared. 4x times minus 1 is minus 4x. And we've now factored 4x squared minus 4x using the distributive property. Okay? Your book refers to this as factoring out the greatest common factor. So that's another way to talk about it. Let's move on and look at example D. I need to erase and make some more board space to do this. So example D, I want to factor the polynomial 6x squared plus 3x. So I want to factor 6x squared plus 3x minus 15. Okay? This time it's 3 terms, but we're going to do it in the same fashion. We're going to use the distributive property. You first look for some factor that's common to each of these three terms. Well, 6, 3, and 15 are all divisible by the number 3. And in fact, 6x squared, right, you can think of that as 3 times 2x squared. 3x is 3 times x. And 15 is 3 times 5, if you think about it. So 3 is your common factor in each of those cases. There's 3 appearing in each of those terms. That's what you're going to take out using the distributive property. So we're going to take out that 3, and we're going to be left with 2x squared plus, and here when you take out a 3, you're left with x, and here when you take out a 3, you're left with 5, or minus 5. You now have a product of 3 times this, and there's nothing else that you can take out of there. So you're finished with that one. And I want to point out that I write this step in here right now just because we're getting warmed up. We're learning how to factor. But eventually, most of you should be able to go directly from the first step directly down to the second step and not have to write this. You can do this in your head. But I'll keep writing it just for our notes. Let's do another factoring here. Let's look at 14m squared n, 14m squared n, plus 21mn. An interesting polynomial. 14m squared n plus 21mn. And I want to take out the greatest common factor. So first of all, looking at these two here, what number is common to both 14 and 21? I think the number 7 divides both of those. And then you have the m squared, the n, the m, and the n. So let's see. 14 is 7 times 2. M squared is 2m's with an n. 21 is 7 times 3 with the mn. So if I break it down, I have 7 times 2 times m times m times n, 7 times 3 times mn. Again, this is what you're thinking. You don't have to always write this step in. And in fact, after a while, you're going to stop writing the step. Now let's see what's common here and here. Well, we definitely have a 7. What else do we have? We have an m appears both places. And we have an n that appears both places. So what you're going to take out is 7mn. You can take that out from both terms. So let's take out 7mn, 7mn, and you're left with, in the first case, 2m, and in the second case, the only thing that will be left over is a 3. Let's check that. 7mn times 2m is 14m squared n. 14m squared n, which was up top. And over here, 7mn times 3 gives us 21mn, which is up top there. And so that is the factorization for this polynomial. Okay. Okay, let's look at one more polynomial. Let's look at f. F reads as follows. F is the polynomial 6x cubed plus 3x squared plus 8x plus 4. Okay? Is there anything common to all of those terms that we can factor out? Well, let's see. The first two terms we could take a 3 out, but we can't take a 3 out of these. There's x cubed, x squared, x, but there's no x here, so we can't take an x out of that one. So it doesn't look like there's any number we can pull out of that. So there are no common factors to remove. Let me just write down here. No factors, no common factors to remove. so we can't take anything out. However, there is another way to express this weird polynomial as a product of smaller polynomials. And in fact, that leads us into the next topic, which is called factoring by grouping. Let me write that down. So the next part, which is also still section 5.1, is called factoring by grouping. Factoring by grouping. Factoring by grouping. And you can factor by grouping whenever you have a 4-term polynomial. So this is used on 4-term polynomials. And so I'm going to write that down. That's the only time you can use it, is if you have 4 terms in your polynomials. Not 3 terms. You have to have 4 terms in order to use factoring by grouping. So let's do some warm-up exercises first. Then I'll tell you how to factor by grouping by doing that example over there. Okay? So let's warm up. And so let me just write here. We're going to warm up here. And we're going to practice using the distributive property. And I'm going to do the following. Let's take x squared times a plus 2a. X squared times a plus 2 times a. If I want to factor this, I want to take out the common factor, and the common factor is a. So when you take out a, you're left with x squared plus 2, and so you have a times x squared plus 2. Compare that to this example. Let's take x squared times x plus 1 plus 2 times x plus 1. Repeat. Let's take x squared times x plus 1 plus 2 times x plus 1. Notice how this is very similar to this one here. Here, I had a letter A, and that's what I took out. See, my letter A, that's what I was able to take out. Here, I have a common expression. X plus 1 appears in both places. And therefore, when I go to factor this, I'm going to take out x plus 1. So here we go. Let's take out x plus 1. That's what we're taking away from these 2 terms. When you take x plus 1 away from this first term, you are left with x squared. You're left with x squared. When you take x plus 1 away from this second term, you're left with 2 plus 2. Notice x squared plus 2 is the same above and below. And the only thing that's different is instead of a, I have a quantity x plus 1 that I took out in front. So the final product here is x plus 1 times x squared plus 2. Okay? Keep this in mind. We're going to use this technique as we factor by grouping. Okay? And actually, just to practice, we'll do one more practice. Let's take 3z squared times 2z plus 1, 3z squared times 2z plus 1, plus 2z plus 1, and we want to factor this. Okay, just factor this. We're still warming up here. Notice 2z plus 1 is common to both of those places there. And we're going to remove the 2z plus 1. So we're going to take out 2z plus 1. And what we're left with is 3z squared plus, and remember this is one of those tricky ones, when you take this away, you're left with just the number 1, right? So that's 3z squared plus 1. Okay? And that's a product expressed from this polynomial. All right. So let's now use that warm-up that we did there and apply it to polynomial number f, which was 6x cubed plus 3x squared plus 8x plus 4 This is a 4-term polynomial, and we couldn't take any factor out. So what we're going to do is we're going to factor by grouping. So let me write down factor by grouping. And here's what you do. The first step when you're factoring by grouping is to do as follows. The first thing you want to do is you want to group terms into pairs. Group terms into pairs. Group terms into pairs. So here we go. I'm going to go up to my top polynomial, and I'm going to group the first 2 terms together into one pair. And I'm going to group the second 2 terms together into another pair. Okay? And notice there's still a plus sign in between. There should be a plus sign there. Now we can proceed to the second step. And let me just erase these words so they get out of our way as we work the problem. Second step. Okay? Use the distributive property on each of these quantities. So now, factor out the common term for each pair. Let me read that again. Factor out the common term for each pair. So, let's take the first pair, and we're going to factor out the common term. So, the common term here, what can I take out? I can take out a 3, and I can take out x squared. 3x squared. And when I do, I'm left with, and you can check, 2x, because 3 times 2 is 6, x squared times x is x cubed, plus 1. That's the first thing. In the second one, I can take out a 4. When I take out a 4 from both of these places, if I take a 4 away from here, I get 2x plus, and when I take a 4 out from here, I get 1. So that's 2x plus 1. And now, the third step, okay, the third thing you want to do is you want to use the distributive property to take out the common expression. So now take out the common expression, or factor out the common expression. You'll have a common expression when you're done. So we're going to take that out. So when we go back up to our example, looking here, your common expression is 2x plus 1. That's in both places. So you're going to take that out. So we take 2x plus 1 out. And what are we left with? We're left with 3x squared plus 4. This is now a product. And the final thing that you should do, okay, which is the fourth step in factoring by grouping, the final thing you should do is check your result by multiplying. So check by multiplying. Check by multiplying. Okay? Check your final result by multiplying to make sure you've done it correctly. So we'll do that. I'll go back to my answer here, and I'm going to check it. 2x times 3x squared is 6x cubed. 2x times 4 is 8x. 1 times 3x squared is 3x squared. 1 times 4 is 4. You should be able to check that. Compare that with the original polynomial we were trying to factor. So let's go back up to the top and see if we can get a broad shot and compare. Are they the same thing? You have 6x cubed, you have 8x, you have 3x squared, and you have 4, both in the answer and in your checking. And therefore that is, in fact, the same polynomial. And so that is the factorization of the top. So let me review. When you factor by grouping, the first thing you do is group into pairs. second thing you do is take out the common factor for each of those individual pairs. The next step is to take out the common term, and then always, when you're done, check your answer by multiplying. Okay, I think you'll have fun factoring. Practice the factoring by grouping, and the hardest part is when you get the negatives involved in the second pairs and the first pairs. Make sure you see me if you're having questions, and like I said, have fun. So next time we'll start section 5.2, which is factoring trinomials. See you then.